In this video, I'll go through how I install these socket outlets while complying with the Australian wiring rules. Feeding off double GPOs is a very common task for first year apprentices when they first start out in the electrical trade. And I'll show you some of my best practices I've learned over the past 5 years, but pretty much I make sure when I rough in my cable, it's done neatly. I ensure my wiring installation is always complying with the AS3000. I fit off my outlets in a safe and efficient manner. And lastly, I make sure those damn things are level. G'day everyone, my name is Corey. I'm a licensed electrician from Melbourne. Welcome to the first video in my new series called The Electrician's Bible, where I go through the Australian and New Zealand wiring rules standards and show you how I apply these legal requirements practically on the job. In this specific video, I'll be covering double socket outlets, which are these things. In Australia, we usually just call them double GPOs. And the specific socket outlets I'll be talking about in this video are the ones that are rated up to 10 amps. And the book is right behind me here. I mostly just refer to the PDF version I have on my computer, which I got from trade school. So you can get this thing for free from trade school. Otherwise, you got to go to like the standards website and it costs you like 200 to 300 bucks, which don't know why it's so expensive, but yeah. While you're at trade school, download all the standards you can. This is the 2018 version. There are a few amendments that have been introduced. I haven't added it to this book, but you can download those amendments for free. And I know this thing can be quite intimidating for first year electrical apprentices, but it really isn't that hard to navigate once you understand its layout and how it's sequenced. I'll quickly tell you how this thing is organized. So pretty much you've got 8 sections and you've got some appendices at the end. When you go to section 1, that gives you sort of a list of other standards, and you're mainly going to be looking at definitions in this section, especially for your tests and exams at trade school. And then from there on, picture wiring up a garage. Where would you start? Well, we're going to start at the switchboard. That's section 2. That'll cover all your switchboard requirements, your circuit breakers, your safety switches. All of that is in section 2. Then we go on to section 3, which is your actual wiring. So the wiring that goes from your switchboard to your appliance, whether that's the lights in your garage or the power points in your garage, that wiring is all covered in section 3. And then from section 3 to section 4, you've got your appliances. And yeah, that's your power point, your lights, pretty much anything that you're going to connect your conductors into. That's what section 4 covers. From there, you've got section 5, which is your earthing. Once you move on to something a little bit more complex than a garage, say a domestic situation such as a townhouse, you'll have bathrooms and you'll have a laundry and you'll have showers and all that jazz. And that's what the next section 6 covers, damp situations. And then when you go from section 6 to section 7, you're going to be dealing with things that are a little bit more niche and a little bit more complex in a way, which is your special situations. So like your caravans and like your medical places and all those other sort of weird niche areas will be covered in section 7. And then from there, the last thing you do at the end of every job is you test and verify. And that's covered all in section 8. It'll actually tell you all the mandatory tests you've got to do, and it will give you the passable results. In terms of the kind of protection we give to your general power circuits that have these double GPOs on them, it's usually protected by a 16 amp or 20 amp RCBO. And what I mean by RCBOs is they are circuit breakers and safety switches combined into one. And safety switches are also known as RCDs, or residual current devices. And what they do is they protect people and livestock if they come in contact with live terminals. Pretty much what it does is it monitors the difference in amps between active and neutral. And if there's a difference, then the safety switch will trip. And pretty much what circuit breakers do is they trip due to overcurrent when like a short circuit occurs. And so these things are just 2 in 1. Clause 2.6.3.2.3.3, which is a bit of a mouthful, I think it is, gives you the minimum requirements of circuits that have to be protected by an RCD. And it states that any circuit that's rated on a 32 amp circuit breaker or lower needs to be RCD protected. If these things are usually protected by 16 or 20 amp breakers, then we're going to be putting an RCD on them. The minimum cable size for these socket outlets are 2.5 mil, 2 core and earth, TPS. This is the most used type of cable we have for socket outlets. And yeah, that's that flat white cable that has an outer sheath, and then you've got inner insulation, and then you've got the conductors. And what I mean by two core and earth is you've got two cores, which is your active and your neutral conductors, and then you've got earth, which is your earth conductor. And yeah, that's what we use for power circuits here in Australia. You are, however, allowed to use 1.5 mil TPS on socket outlets, and 1.5 TPS is what we usually use for lighting circuits. But the only situations you're allowed to use that is for socket outlets that are above 2.3 meters or are supplying an appliance that are rated under 150 watts, I'm pretty sure. Clause 3.9.3 covers your support and your fixing, so how you're gonna actually run the cable, support it, make sure there's no undue sagging. Clause 3.9.8.2.2 covers your segregation between low voltage circuits and extra low voltage cables. For example, as electricians in Australia, we deal with low voltage circuits. That's your 230 volt single phase circuits and your 400 volt three phase circuits. And we've just got to make sure we've got segregation between these circuits and our extra low voltage cabling, such as your Cat6 data cabling or your coax TV cabling. You will have sparkies out there that tell you you're allowed to cross them like that. So for example, you know, we've got the power cable coming down the wall like that. We've got data crossing behind it or in front of it or whatever in the wall. You'll have sparkies out there that will tell you that's allowed because the electromagnetic field that the TPS creates doesn't interfere with that Cat6 cable. Well, I'm just going to tell you now that's actually kind of bullshit, and I don't know where that started. There's nowhere in the wiring rules that state that you can cross paths. Maybe I'm ignorant somehow, but what I do is I always make sure they're segregated. What I did for a specific job when they were going to cross and I had no choice, I just put a bit of corrie over either the data or the power cable so that you've got mechanical protection, and that counts as segregation. Clause 3.10.1.1 and then note 2, I think it is, gives you the minimum requirements of unsheathed cable behind a hole in a wall. For example, you know, you cut out your hole for your power point. And a good way to make sure you're not going above 100 mil is to literally get your pliers out, measure 100 mil on them and do like a mark with your texter, so that every time you strip cable for a power point, you just put that mark next to the cable and then you course it, and you know your cabling is complying with the AS3000. Clause 4.4.5 gives you the phase sequence of power points, and pretty much what that just means is it tells you what has to be active, what has to be earth, what has to be neutral when you're facing the power point like that. So going in clockwise direction, you start from the radial line. That's the wording they use in the wiring rules. But pretty much that's just your bottom line going up vertically. That's your earth, and going clockwise, that's your active, and then that's your neutral. And this is good for when you're testing live circuits with your multimeter or your fluke test or whatever. Clause 6.2.4.2 gives you the minimum requirements that power points need to be above the floor in bathrooms and laundries, which is 300 mil. Usually when we're roughing in cables for bathrooms anyway, we're not locating power points near the floor. It's usually above the vanity. There are also rules in terms of how far power points can go near sinks and showers and baths. I'll quickly go over the sink rules, which in the AS3000 they are referred to as fixed water containers. They pretty much figure 6.13 and 6.14 will give you the exact dimensions that power points have to be in terms of their proximity to those fixed water containers. Figure 6.13 gives you the dimensions of sinks that are able to carry under 40 liters of water or liquid or whatever. And the rules are you have to be a minimum of 150 mil next to the sink. And then from that 150 mil, you can think of it sort of like a vertical plane up, which goes 400 mil up, and sort of that box, or I don't know, your cube around the sink, you can't go within that zone. I think it's like zone 0 or zone 1. Power points aren't allowed to be mounted in that zone, but outside that zone, in zone 2, they're allowed to be mounted. And then figure 6.14 gives you the requirements for power points near fixed water containers that are above 40 liters. And the rules are it has to be a minimum distance of 500 mil next to the sink and at least 1 meter above. Now you can go within zone 0 as long as the power points are in a cupboard or your medicine cabinet. Lastly, when we're talking about the Electrician's Bible, table C1 and C2 in like the appendices towards the end of the book gives you the maximum demand. And what I mean by maximum demand in this case is it'll tell you how much amps like one of these double GPOs are worth. So in a domestic situation, when we're dealing with double GPOs like these, between one single outlet, just a single one, and 20 single outlets, that is worth 10 amps on that circuit. In terms of how I actually rough in these cables on site and how I fit them off, most of the time these power points are going to be roughed in like lounge rooms, dining rooms, open areas. And what I do during the rough in stage, I bring the cable down to the ground level. So that's the amount of cable I rough in. When I say rough in, I'm just saying, I know I've been using that word heaps in this video, and if you don't know what I mean, rough in is just literally running out the cable and installing it where it needs to go. If I can, say it's like a new build, I get some spray paint and mark where the power point is going to go. So when it comes to the cutout phase, when I cut out that power point, I know exactly where my cable is. I also take photos of everything. When I rough in my cable, I tape the ends up twice. So even if it's just a single end, I'll tape up the end of the cable and make sure I cover all the copper, just in case, you know, you've got other trades on site, especially if it's a new build, like a new apartment building. You just kind of want to cover that copper for a peace of mind. Obviously it's not going to be live, but yeah, it also protects from like cuts because the ends of cable, like the copper, can be quite sharp. I'll tape it twice so that cutout stage, fish out the cable, I know that I've grabbed all the cable out of that wall because I see that it's been taped up twice. When it comes to the cutout stage, we'll get a tape measure, 300 high, mark that, get out my little pocket level. I've made a video on this pocket level you can watch. I'll put a link in the description. Cut it out with my plaster saw, grab the cable out, strip it, fit it off. When I'm fitting off a power point, I make sure I twist the strand of copper and fold it in half if it's a single end. If there's like multiple ends, I'll twist the copper together, put them in the terminals, get my impact driver on the lowest setting, tighten that up, and finish it off manually with my screwdriver and just tighten it up. Just so I know at the end of the day that those screws in the terminals are tightened securely. And then yeah, in terms of how we mount these things, most of the cases we're going to use plaster clips or C-clips, and that's what we use in Australia. You can also use stud brackets, which go on during the rough-in stage. So if you're dealing with timber studs, then these are good for that. But even when we're dealing with timber studs and not metal studs, we still usually just use the C plaster clips. They're really easy to work with. And yeah, for surface mounted stuff, we use mounting blocks. And yeah, I think that really covers sort of the basics of how I, as a licensed electrician, fit these things off while complying with the AS3000 and any other standard that we have to follow. I hope you enjoyed this video. I hope it was entertaining and educational in a way. Please give this video a like and comment away any other video ideas or your thoughts. Check out these other videos here, and thanks for watching.